All right, welcome back. We are Game 2014. That's Mobile Game Dev 1 in the fall 2021 semester at George Brown, and it's week 10, part 1 of our broadcast. And so welcome back, everybody. We're sitting here, and this week we're going to be talking about platforms and some player movement, and it's supposed to be some simple enemy AI that I'm wrapping into this week. So that is what Lab 7 is all about. Assignment 2, Part 2, or Part 1 has been released again, due next week. Lab 7 is due this week on Friday. And what we want to do with our demo is add enemies, some simple AI sensing, as well as fix up some of the platform stuff and everything else that we didn't quite get done last week. So our starter this week, there's no theory, but our starter last week was from Lab 6, this one. And what we're going to do is we're going to just get that Lab 6 from GitHub, and that's what I recommend for you. That's our starter. So if we go up on GitHub, and if we look at Lab 6, right? So there's Lab 6, and this is the link for our starter, right? So this is our starter. But I want to make, before you go there, instead of downloading the starter, what I recommend to you is let me make the starter, and I'll put it up. And that starter is the one we want to start with. It'll be called Lab 7. So it's going to be just like this one. It'll be a duplicate of this one for the most part, but there'll be some changes. Give me a second while I create your starter, okay? Or I'll just call it the GitHub link for Labs for Lab 7, okay? It's the same thing. So let's do it. Let's pull this down, and I've already got it here. So in my OneDrive, I've got Lab 6, and I want to make a copy of it. So there we go, and I'll make a copy of it to Lab 6 copy. It's going to copy everything, including all the library file for now, and it's going to take, it says about 5 minutes. It's way too long. So I don't want that, and that's why I don't do that. Let's try that again and go to, I'll be okay. Today is one of those days. That's why I don't copy it. Lab 7. And Lab 7 will be everything from Lab 6 except the library folder. And we'll let Unity do the work for us. Actually, it works out to be faster than doing that direct copy. Notice it was like 5 minutes for me. It's way too long. So this way it's a little bit quicker. All right. We'll wait for this to happen. Okay, now that we've done this, again, I want to directly put this up on GitHub, but what I want to do is first open it in Unity. So I'm going to open it, and I'm going to select Game 2014 Lab 7 and click Open. All right, and as it's opening, hopefully you guys are with me doing the same thing. But it's not 5 minutes, which is the whole idea. Fixed delta time ever change? Well, it depends on where you're using it. If you're using delta time, a fixed delta time in a update function, that is probably a good place to use it. But you don't need delta time at all in the fixed update typically. right? So we're using fixed update to move, not update. So that's why any kind of delta time. Now that question, fixed delta time versus delta time, that's something that you'd look up in the, I'm not sure actually. Let's take a look at that in the Unity documentation. All right, so just starting off here in the scenes, if I double click on main, I have this little character here. And when we ran it last time, what we have is they move around, but there's no animation. We can jump and so on, but that's all. What we want to do is add animations, finish the animations, add platforms, more platforms, and moving platforms and an enemy. Lots of stuff to do and not a lot of time to do it. So now let's just save, file, save project, and then let's exit. And we're going to use Gitkraken, and we're going to put this up on GitHub immediately. So let's try this out. So here I am. I'm going to open up a new one, open a repo. We're going to open a repository that's on my desktop, GBC 2014 Lab 7. Select that folder. That's an existing GitHub repository because I've made a copy from one to the other. In your case, you wouldn't have to do that. You just download Lab 6 and copy it and make a Lab 7. And then you'd have to kind of create your own repository here. So that's one thing that's changed. The other thing is that the remote I want to remove. So let's remove the remote, the origin, and make our own new one. I'm going to stage all changes here, and we'll say updated for Lab 7, right? And then we're going to push this to GitHub, but there's no remote. It's going to ask me where it is. I'm going to select George Brown, and we're going to call this GAME2014 F2021 Lab 7 and create remote and push local references, which is going to create the link that you need for you to check for your Lab 7. So if I go back up to here, then we'll see Lab 7 here. And this is where we're going to go to. Notice that it says Lab 6. Let's change that right now since we're here. So this is Lab 7. And we can update that one. And we'll put this one up on Blackboard. So this will be a web link. We'll say that this is the repo for Lab 7. Okay. And that's what that is. And that'll be where you can check my code versus your code to see if we're on the same page. One thing that we've done is now that I've updated the README, if I do a fetch like I did before, you'll see that there's one README ahead. The main on where it says on GitHub is one ahead from our local. We just can pull that down. And when we do that, it will merge the changes. So now that they'll be in sync in a second. And there we go. Great. Once I've done that, I can reopen our Lab 7 and get going on our project. Yeah, you can work from Lab 7 if you want. I recommend that because I've added a couple of additional packages, Kira, so that let me talk about what I've added. A couple things I've made changes to from last week are I've packaged everything inside of an external with a capital X assets folder. And I've done that just to keep all of our external assets away and down here compared to way up at the top. I've added a joystick pack. I've added, so now you have a few things, a fantasy wooden UI, a Sunnyland forest, Sunnyland and Sunnyland woods, so extra assets in there as well. And one thing that was asked of me last week was, is it okay if we can use the Sunnyland assets for our assignment 2? And I said no. And thinking about it again this week, I'm thinking it's probably okay. And I'll tell you why it's probably okay. Because you're still going to have to pick your own platforms. You're still going to have to make it your own game. You're going to still have to make it your own, mechanic, whatever the mechanic you're going to choose for your platformer. So if you really wanted to use Sunnyland assets, you could. I'm not going to be against it. All right. Again, I'm not going to expand into all the things that you need to do for your assignment, but I'm going to cover some things. All right. So I'm just going to put it out there. So Herman, you asked that, I think, can we use your assets? And I think the answer that I'm going to backtrack on that one and say, yeah, it's probably okay. Just to make it easier so you don't have to find assets. That's really what it is, right? So, okay, so that's the one thing that I wanted to announce today. So what we want to do is we want to do a couple things. One thing is we have our player, and our player right now, like we said, does a couple things. One, we don't have a camera for the player, so let's add that in first. So to add a camera for the player, we're going to use Cinemachine. Sorry, Herman. I'm sorry. Herman says he found other assets. So we want to use Cinemachine. So the way to add Cinemachine in is I want to go to Window, Package Manager, and I want to look at the Unity registry for this lab and go down to where it says Cinemachine and click Install. And again, what the good thing about this is it's going to update stuff. It's going to install Cinemachine as a package, which is what I want to do. I also noticed a couple of additional things. Sprite Shape is needing of an update. PSD importer needs an update, and so does animations. Let's add all that as updates. Let's update to 6.07. I didn't do this with the first class. I didn't notice that these were changed. I did have some weird side effects I want to talk about too when we get to that point. I'm just going to update these ones. You might want to update them as well so that they're the latest version of the Unity registry package, right? So that's all they are. And the last one is the sprite shape. And I think the sprite shape might make a huge difference for us as well. So, all right. So that is all the updates that we want to add in for this one. You can see that there might be other ones, a test framework and a timeline and Visual Studio Code Editor, and even the Visual Studio Editor. I think that's an important update. Anything that updates the Visual Studio Editor is good because that means it'll give you more code hinting and those kind of things with Visual Studio. So anything like that. So update those packages, please. Cool. So now that we've done all the updates and the includes, now we have Cinemachine. I want to add a virtual camera to the scene. So that's the first thing I want to do. So I want to go to Game Object where it says Cinemachine and add in a 2D camera. We're going to call this virtual camera. All right, so Cinemachine actually adds a couple things. It adds a Cinemachine brain to the main camera. That's what it first does. And what it allows us to do is create a 2D camera that kind of follows the player without doing any kind of coding on our end, which is cool. So that's what the virtual camera is for. The virtual camera basically says, hey, what am I following? I want to follow the player. So that's what I want to do. I'm going to look at the player. And if I actually click on the virtual camera while I play, you can actually see the boundaries of the camera as it's playing. So take a look. So here's my boundaries of the camera. And notice that the camera doesn't exactly follow the player. It's a bit behind, right? And that's what we want. We want a little bit of offset or decay, if you will. And that's pretty cool. So this blue arrow, if you click away, then that goes away. It's just, if you just click on the virtual camera itself, you'll see the offset, which is pretty cool. All right, so that is the first part. So the virtual camera is there. And so virtual camera done. Right, so now we have a camera. One thing I noticed though is that it's really close up to the player. And I think a lens ortho size of 10 might be better for what we're doing with our game for the virtual camera. So again, if I save and if I press play, then we can see that that is the case, right? We'll see that that's a little better. We can see that we can actually see more of the screen. And for what we're doing in our game, this is probably much better than what we saw before. Cool. Excellent. The other thing we want to change is just our settings, just because we have some build settings that have changed. In our player settings, we want to change the product name to Lab 7. I forgot to do this at the beginning. I should have done this in setup. This should be 002. And linear color space is what we're using. But the bundle identifier should be Lab 7. Same thing for all the different bundles, whether we're using a WebGL build, right, as an example. For WebGL build, again, WebGL 2 is good, but for Android, make sure that you remove Vulkan. That's there by accident. I guess I didn't remove it last time. And again, the bundle identifier should be 7. Okay. Sorry, I wanted to make that clear so that way we're done with the changes. All right, so that is our camera. So the camera is set up. That's great. These blocks here are going to get in our way. So we're going to remove these blocks because they're going to mess up our jumping. So that's one thing we want to do. So again, I'm going to choose the world, and I'm going to go with our platform layer, and I'm going to choose Open Tile Palette, and then I'm going to choose the little eraser and erase those 3 tiles. So they're gone. Okay. And now what I want to do is I want to test or want to add more animations. Last week, what we did was we added animations for player movement. So we said that, the default animation that we're going to use is the idle animation, right? The jumping doesn't really do anything right now. We want to add a different jumping animation and a moving animation. So let's add that in. So again, I'm going to go into the external assets, into Sunnyland, and into artwork under sprites player, and we see that there's several different animations. I'm going to select the jump animation first, select those 2 frames, change the pixels per unit to 16, and select my resize algorithm to bilinear, click apply. And then I'm going to drag and drop those 2 things into the scene, and it's asking me where I want them. I'm going to put them inside of sprites, animation, and let's just rename this thing as the player dash jump clip. Okay, it's going to create an extra controller. We're going to get rid of it in a second. And we're just going to put it in the scene, and then we can get rid of it right away. So goodbye. And then do the same thing with the run animation. So run animation will take all the clips for run, the frames, change the pixels per unit to 16, and then go with a resize algorithm of bilinear, click apply, and drag and drop all these things inside of the hierarchy, which creates your animation. So again, assets, I want to put them into sprites, animation, and just call this something like player run clip. Okay, so there we go. So there's the run clip. We can delete that item. And now that we have the clips, if we look inside of sprites, animation, we see we have not just clips, but also animators. These are the animator controllers. I only need one, just this one. So I can get rid of these 2, the ones that look like little state machines. Okay, so I can delete them. And then all I have is clips. Clip, clip, clip. All right? Player run, player jump, player idle. And here's the animator controller. And right now, what I have in the animator controller, when I double click, I have this animator window that comes up. You can also tab it over or kind of park it up here. It's up to you where you want to put it. I want to change what this thing is called. I'm going to call this idle. So this is just for the player. And let's also put in the run clip. Okay, so that's going to be the run, as well as the jump clip, which we're going to just call jump. Okay, so that's all the different clips. So idle, run, and jump. What I want to do now is in the animator, right, I want to create, my states, how we go from idle to run to jump. We can use the state machine that's here. So I can right click on my idle and make a transition to go from here to run, right? And notice on the right-hand side, I've got this little preview. Yana from this morning's, or this first section, he said, hey, drag and drop the player in there, and then you'll see a preview of what it's going to look like for each of the clips. I think it's a great idea, so drag that in here, and you can see that there's a little clip or a preview of what the player animation is going to look like when it comes to how I move from idle to run. So that's the transition, okay? So pretty cool. And so again, I can make a transition from idle to run. So I can be in idle state and then I can run, or I can go from running to jumping. I can go from jumping back to idle, but I can also go from idle straight to jump, right? So I can go, I want to jump, and I can go from jumping. If I'm jumping, I want to start running immediately when I jump. When I stop jumping, I can do that. And I can go from running to idle. So these are all transitions we can make. If you right click on any one of these clips, you can add a transition. Okay, make a transition. But I don't want the transition to have two things. I don't want any of these transitions to have exit time, so no exit time. So let's get rid of all those. Make sure that you select all the transitions and remove exit time, as well as on the way back. So no exit time on the way back, right? Don't want exit time anywhere, okay? And the other thing we don't want is, if you open up settings, we don't want any transition duration. So just put 0. All right, so all the transition durations should be 0. So we shouldn't have any of that happen. You can also adjust it by hand, but it's not really required. Okay, so there's all the transition durations to 0. All right, so that's all that's been done so far. If everything is, Michael says, everything is connected, would we want to use any state? Yeah, the only time we want to use any state is if there's a state that we want to go to that's not dependent on another state. For example, the die state. If you get die, if you die or get hurt, my hurt animation might trigger from any state as opposed to the entry state. Okay, so it doesn't have to go. I can trigger it anytime I want. Okay. So let's make this work now. What we want to do is we want to add a parameter. I usually add something like an integer, and let's call this the animation state, right? And the animation state starts at 0. So 0, we're going to assign 0 to idle, 1 to run, and 2 to jump. So what we're going to do is we're going to say when we want to go from idle to run, we want to use this transition here, this line, this arrow that points from idle to run. And on the right-hand side, you're going to see that there's a condition we can click on. We can add a condition called animation state, which is the name of the parameter by default goes in there, or we can choose another one, right? And then equals to 0. So we want it equals to 1, right? So we're going to say when the animation state equals to 1, we're going to push it there, by the way, we're going to start running. And when the animation state equals to 2, we're going to jump. When the animation state equals 0, anytime that happens, right, then we're going to go to idle. And when the animation state equals to 0, here, we're going to go back to idle. So these ones, this one, and this one are the same, okay? And this one goes to 1, and this one needs a state to go to 2. And these are all hard-coded in. Don't you love hard coding? It's bad. Okay, so that goes from 2 to 1, this transition line. So each of these should have, now, each of these transition connections should have a condition to make a transition. The animation state will be equal to 1. That'll take it from idle to run. And the other options are no exit time and a transition duration of 0. Okay. So that's what the animator controller looks like right now, but it's not functional. And it's not functional because we have to make it work, right? So by default, only idle state will trigger. Again, if I run it, you'll see that I'm going to only be in idle state, right? There's idle. And if you want to see the animator at work, right, if I want to pull the animator down here, right, then you're going to see that by default, there's nothing that's running. Not even the animation state idle is triggering. Why is that? Well, because we're not triggering the idle animation in any way, right? It's just going from entry point, okay? So that is what we want to do. What we want to do instead is I want to make it so we trigger the animation. So when I'm moving left and right, I want to trigger the animation to jump to run, or if I'm clicking jump, I want it to trigger the jump animation. So how do I do that? So in code, if I go back to scripts, and if I go back to player behavior, right, then what we want to do is we want to get a reference to the animator that's inside of our player. So again, if I go back to Unity for a second, and if I go to player, player has a sprite renderer as well as an animator. And the animator controller is right here, player animator controller. This is the one that we created when we first created our idle animation. It was created the first time, and that's the one that I've been clicking on down here. the player animator controller. Okay. So what I want to do is in my player behavior, one day when it decides to go there, I want to get a reference to my animator controller. So we're just going to make a private reference. Come on. We'll call this the animator. And we'll call this the animator controller. So we know what it is, right? And the animator controller in the start function will say that animator controller is equal to get component animator, right? So we'll get a reference to it just like we've done with rigid body, right? And the animator controller is something that we can trigger we can change the integer variable that we want. So we can say something like, hey, when we've already kind of have something like this, right? When we check for flipping, we're saying when the value we're getting from the get axis raw on the horizontal, x is not equal to 0, we flip. Well, we also know that if x is not equal to 0, we're moving. So we can use this same if statement for that. We can say that, hey, animator controller, we want to set integer, which is called animation state, to 1, which is really shifting to the run state. That's what this is, the run state. So that's what happens when I move around. When I press X, then it's running. How about down here if I'm not grounded, then I'm falling or jumping. So I can say else. We can say that that is where I am jumping. So I can put that down in there and say that when animation state is 2, right, we're in jump state. Okay. When do I get back to idle state? Well, that is when X is something like greater than or less than 0. So that's else here. So I can say that for now, we can put a run or an idle state, call this idle, down here. So we're going to set the idle state when we are not at 0. So, sorry, when we are at 0. So this is when we are at 0, this is when we're not at 0. So if we're not at 0, we're setting the animation state to 1, we're running. If we are at 0, which is down here, then we're setting the animation state to 0, which means we're idle. Let's see if this works. And again, all I've done is I'm triggering the animation now by setting the integer. So this is one way of doing it. There's other ways by using blend states and so on. And now look at that. That is triggering, right? So let's just bring this a little lower. And you can see that now what we want to do is we can move from idle to run to jump. So for example, if I press the jump, you can see that the jump animation plays a little quick though for me. And if I run, you can see that no matter where I go, I can trigger the run animation and it's kind of triggered immediately. Okay. All right. Are you with me? Kira says in Unity C# a float is equal to 0 when it's positive or negative epsilon, right? If it's equal to 0, yeah, because epsilon is a close enough number that is there. It's like very close to 0, right? Yeah, you're correct. Because remember, we can't be quite 0 because it's real numbers. Yeah, sprite size needs to change to 16, right? And then you'll be there. All right, so let's stop this and we will put this up here again because we don't need this anymore. So that is your animation state change. So we're state changing when we're playing, and the way this is working is, again, if I'm pressing the left, kind of button, we're moving, slide a little bit, but that's just a factor of the way we've done our motion. Okay. I also noticed in the first class that when we were testing last week for the player, I felt that the vertical force was not enough. I put it back to 40, and I felt that was better during testing. So if I was to show you this, you can see that if I go to 40, I think that's a better, kind of test. And one thing they also talked about in the first class was, hey, what about air control? If I want to be in the air and then turn to the right, I can't do that. How do we add air control to this one at all, right? So again, I think we can add error control in, and then we'll stop with the controller being completed, because that's something that we want to do. And what I mean by error control, again, for the people that are, um, you know, that maybe don't know, it's like when I'm in the air, I still want to be able to move somewhat, a little bit, but not enough where I'm actually, adding too much to my movement, right? Because I don't want to move twice. I only want to move once. So we're going to do some duplication, and later on, what we're going to do is we're going to fix it, and because we don't want to duplicate code. So a couple things that we want to do is I want to also be able to track my state. So if I wanted to track my state in the editor or in the inspector, let's say I want to know what animation state I'm in, then what we can do is we can create an enumeration, and an enumeration might make it cleaner because it's not going to be as hard coded as we are right now. So a couple things. Let's add in a new C# script, and we'll call this player animation state. All right, the player animation state script. You have to wait for a second while it generates it. There it is. I was rushing in this earlier class and got myself into trouble. Double click. It's going to bring up this. I want to remove mono behavior because I'm not going to use a class. Instead, I want to rename this into an enum. So it's going to be called the player animation state enumeration. We're going to have a couple of states. One of them is idle, then it's run, then it's jump, and then we're going to have number of animation states, right? It's the number of animation states. And that will be our little animation. Because I'm a nervous guy, I like to use system.serializable. Although earlier in the earlier class, Maxim pointed out that you probably don't need it if it's a public enum. Okay. All right, so cool, I got this. I'm pretty happy with what this looks like, but how do I use it with player behavior? Well, what I can do is I can create an animation area. So I can say header, and we'll say that the animation area is called animation, where I have a public player animation state. We'll call that state. And that public player animation state, we can set that up so that when we are moving, when I go to the run state, I can set it. I can say that this state is equal to the player animation state idle, so I can keep track of it. In fact, instead of using a hard 1, I can say that this is player animation state.idle, but because it's an enum and not an integer, we need to convert it, which is cast it as a. And the same thing goes if I want to do idle, right? So I want to do the idle state. Sorry, this would be idle. The other one would be run. Like, see, I can even detect the issue right there. Run. This would be run, right? This would be idle, right? And I can set this to idle. And when I set the state to idle, it's just for debug purposes right now. But later on, maybe I want to make it so I can force the animation to whatever I want. So this will be the idle state. And the same thing goes if I want to use this further down. So why am I doing this? Because it's easier to look at. You know what the animation state is without my comments, right? The jump state. And at the same time, I can always view where I'm at in the inspector. So that's why I'm doing this right now. So I can say that this is the jump. All right, so once I've done this and I go back to the inspector, then inside the player, you're going to see that there is an idle state. And if I run it, when I jump, you can see that I'm jumping. When I'm moving, I'm running from left and right. So that's that part. Yes? Air control. So one of the things that was asked about earlier was, wait a minute, what about if I want to add air control? And yeah, we can do that. One thing we removed last time was delta time. We can remove that still because we're into using fixed update as opposed to regular update. And with air control, we want to be able to access the um, horizontal, get access raw horizontal. We want to be able to do this all the time, but we want to get the movement, which is happening down here, right? There's a movement part we worked on last time, which is pretty much all of this, right? We talked about all of this, last day. Let's just remove some of these comments. We removed delta time, right? I want to kind of do this again when we're jumping. So this is when we're grounded, but when we're not grounded, which is in here, we want to kind of do the same thing that we did up there, but to a lesser degree. So we still want to be able to flip animation all the time. So anytime where x is not equal to 0, we want to be able to flip animation. So what I did last time was I took this not equal to 0 thing, and it depends on where you have it. That's when I want to flip the animation that's down here. So that is universal now. I don't want to limit it to is grounded or not, right? So for now, let's do it one step at a time. We'll take this piece, right? And we'll put it down in here. And we're going to see that that's probably not good because we don't know what x is. So then what we want to do is up at the top, we want to remove our x input from here and put it right inside of move. So we always get input from the x-axis in this case, okay? Again, this is just using keyboard controls for now. Later on, we'll use a joystick of some kind. So this is the first point. So float x is equal to input.getx is raw horizontal. And we're always going to get this regardless because we want it whether we're grounded or when we're using air control. Yeah, this is the air control section, or when we're not grounded, we're falling or jumping, okay? So this is pretty cool. So then x makes sense. We're going to flip the animation. We can flip the animation in the air now, right? Whether we're in the air or not. So that means that theoretically we can probably move this outside of the if else loop because we're always going to be able to do it. But hold tight. One thing we don't care about is changing our animation state. We don't care about this piece, right? So that's where it's different. Or setting the animation state at all. We don't care about this. So the only thing we really care about is flipping. And this is where it's different, okay? The next thing we don't care about is all the movement. We don't care about jumping force because I don't want to do a double jump right now. I do care about mass and adding force, but not velocity. So all of this should be here, which means I may require a some kind of other function potentially. But for now, we just want to make it work and we'll refactor later. So this will give me the same effect whether I'm jumping, grounded or not. It'll allow me to move horizontally, but we want to scale our horizontal move when we're not touching the ground. So we have some control in the air, but not full control. So let's call this the air control factor that we're going to put in at the bottom. So under ground layer mask, we're going to put another public float, which we're going to call the air control factor. It's going to be like a multiplier, if you will, that is going to reduce the effectiveness of my motion, right? So horizontal force multiplied by the air control factor. We're going to use it to reduce what it's going to be done, what it's going to be, and it should be something between 0.1 and 1, which means our air control factor should be scaled. So this should be a range. We'll limit it. We'll say that it's between 0.1 F and 0.9 F, but not quite 1, right? That's what our air control factor is going to be. And if we go back to here, to our game, we see that we have an air control factor, and we want to start with something like 0.25, but you can see that we have the ability for us to go from 0.1 all the way to 0.9, but nothing else. And this is kind of a limiting factor we want to put in. So I think 0.25 might be a good starting value. You can also type it in. Here it says, can you get the number of states via a script? Are you talking about from in C#? Yes, you can. Yes, you can. Yeah, you can. You can measure the count, the number, the length, if you will. All right. All right. So again, we can see that this is what we want to do, the error control factor. So now what we want to do is when we jump, let's see if this works. When we jump, we want to be able to use the error control factor to, so whether I'm moving up or not, right? I want to move back, and it's not bad when I'm at thing. Now also we fall to oblivion. We're going to fix that. But 0.25 might be too small. Let's go 0.5. That might be a better scaling factor. So if I jump off the edge of the platform, I should be able to come back to some point. Okay. All right, so that's the one thing. The next thing is, so error control factor looks like it's not bad. Again, it needs adjusting. Some of these forces may need adjusting now because we're adding in, additional force when we're moving. So that is something we may need to adjust or tweak. The other thing I don't like is the whole jumping thing. So when I jump up and down, right, our jump is really, really fast, right? And I want to kind of make that slower, and you can do that in the animator. So in the animator, you can choose jump, and where the motion for the clip, I'm just selecting jump here. I can change that to like something like 0.5, which is half the speed of the animation frames. All right, so I'll save that and run it. And if you notice, the jump now will be a little bit slower. And even when I'm falling, it's just falling. All right, cool. So that is player motion. I have air control. I have animation, all the stuff that we potentially might want for our platforming game. Let's file, save project, and close down Unity and put this up on GitHub. So again, going back to here, I'm going to view changes and say something like added animation and air control to players, right? So good, stage all changes. We can commit these changes to 20 files, and when we're done, we'll push them to GitHub. Awesome. So now that we're up to date, let's go back to here and run Lab 7 again. Okay, back to you guys. Are you with me in terms of what we're doing? So player movement is mostly done. We got a camera, which is pretty cool. So we got a camera moving around. We've got player movement. We've done most of what we need to start with the platforming mechanic. What we want to also do is add additional platforms at this point and a death plane, because I don't want to keep dying and then I'm going forever. Let's do the death plane first. So here I want to add a brand new, again, 2D object tile map, rectangular. We'll call this the death plane. Okay, there's the death plane. And in the death plane itself, when I'm clicking onto it, I want to add a new, so I'm going to draw the death plane underneath the regular plane. One thing to do to differentiate the death plane from the regular platform layer is I want to color everything in the death plane to red, right? A red color. So all I'm doing is changing the tile map color on the death plane only to red, okay? And then when I click on the open tile, if I was to select the tile, like let's say, for example, something like this, it's going to appear red in the scene. So I wanted kind of the death plane to be way, but let's say this is the lowest platform. I want it to be something like down in here, right? And I can draw, I can draw the death plane, right, way over here. And let's just make it so that I can draw it much larger. If I could do it straight with the way I wanted to do it. And we can just erase the ones that I messed up. Who cares? There we go. All right, so that's a pretty long death plane. that we have. And when the player, let's also maybe extend the death plane so that it is way over here too. So that way, if the player decides to jump this way or whatever, then the death plane would stop over here too. All right, so there's a death plane. We can add more to it. If we ever want to, we can add a ton more to the death plane. It's not a problem. But the thing is that we need some kind of collision system for the death plane and so on. And that's cool. So let's get rid of this. And so for the death plane, we want to do the same thing that we had before. So I'm going to click on Add Component, and I want to add a tilemap component. Right, so there's my tilemap collider, but you can see they're individual colliders. And so now I'm going to add a Composite Collider, and I'm going to say that the tilemap collider is going to use by composite, which makes it all one big collider, which is pretty cool. And I want to make sure that our rigid body is static, right? So it's not going to fall into oblivion. That's my death plane. So if I run it now, and if I fall onto the death plane, then I'm good. You can see that I'm falling forever still, but I'm on the death plane. Can't jump, kind of move, but I'm stuck, and that's okay. So now what I want to do is when I land on the death plane, I want to teleport back to my starting point, which is going to be my spawn point, my player spawn point. Let's add a new empty object. So again, create empty. We'll call this player spawn point. And the player spawn point will be a location in our game world, right? Where we can say, I want to put it over here now, as opposed to over here. Then this is where when my death plane, something falls in the death plane, my player will respawn at this point or reposition themselves at this point over here. The camera will also move there. All right, so how does that work? We need another script. So script, we'll have a new C# script. We'll use the death plane controller. There's my death plane controller. Let's wait for it to generate for a second. Give Unity a second. There it is. And double click. Death plane controller. What do I want to do? I want to use a private void on collision enter 2D, right? For collision 2D other. And we're going to say that if my other dot game object dot compare tag is equal to the player, then what I want to do is I want to teleport back or move back to the spawn point. So I need to reference the spawn point here, which is going to be a public transform. So we'll call this the player spawn point, just the same as what we called it in inside of the inspector. And we're going to say that the other, which is the player dot transform dot position is going to be equal to the player spawn point dot position. All right, so that's going to teleport us back to the spawn point, and we don't need these for now. That is our script for the death plane controller. And we're doing this. Someone mentioned earlier, well, what if, shouldn't we put the death plane or the spawn point inside the player? No, because what I'm going to do is create a system of checkpoints, a checkpoint system, and that will allow us to teleport back to the active checkpoint. For now, we just have one spawn point, but that's not really what we're going to have eventually. All right, let's move away. So we'll go back to Unity, and we want to attach the death plane controller to the death plane, which is actually a whole layer. So death plane controller, hello, and get the player spawn point, which is right here, right? And then now if I run this thing and if everything works, oh, there's one thing that's not going to work. The player itself needs to be tagged as a player. Make sure you do that. Now to run it. And when we do that thing, we're going to see that if we drop down, we instantly come back. If I drop this way, instantly come back, which is kind of what we want because we don't want to keep starting the game over and over again. So that is the death plane and the death plane controller. However, I also want to be able to move my player anywhere where I put my spawn point to start off with for testing purposes. So let's add another empty game object, which we'll call the game controller. And the game controller will have its own script. So for now, we'll call this game controller. And the game controller script is going to be connected to the game controller object. There we go. And we'll double click this script. And we'll say that we want two things. We want access to the player, which is a public transform. We'll call this the player. And we also want another public transform, which will be the player spawn point for now. Okay. And we're going to say that at the beginning, the player dot position is going to be equal to the player spawn point dot position. So wherever that starts, that's where you want it to start. We'll get rid of the update function just to clean that up. And this will just be a starting point wherever we put that spawn point is where the player is going to appear. So we don't have to move the player or the camera or anything like that. Just move the spawn point. And that's when the, so if we want to test different parts of the level, we can move the spawn point wherever we want. Okay, cool. Save. And let's go back to this. And let's see how that works. So let's test it. If I move the spawn point into space, like over here, we should be able to do an endless spawning. Okay. So it'll spawn, then fall, and it'll hit the death plane and so on. Oh yeah, I forgot to add the references for the game controller. We need a reference to the player and the spawn point. And then run. And let's try that again. So now we should see endless falling forever and ever because we moved the spawn point where we put it. Again, if I take that spawn point and put it back where I think it should go, which is over the platform, then when we press the play button, we're going to see that the player falls onto the platform, which is pretty cool. So that's the spawn point. File, save project, close off Unity, put it up on GitHub. Yes, sorry, we're going to do Kara suggests we make the player's collision detection on the rigid body set to continuous mode. I agree, because we had problems that are in the first class as well. And let's do that later. But for now, we're going to view changes. We're going to say stage all changes. And we're going to say that we added death plane. Okay, so commit change to these 5. And we're going to push it up. Awesome. We're going to go back to this and play it again. Let's make that change that Kira recommended, which is changing the player's collision detection in the rigid body to continuous, because of if you fall from a long distance, it'll go right through the death plane and other side effects. So again, player, if I go to the rigid body of the player, we should change the collision detection to continuous and press save. Excellent. So we've prepared ourselves for this. I want to add another platform that looks similar to this one. And I can certainly go through and in the platform layer, I can click on the open palette and draw it out again. A couple things to note is we want to be able to draw these platforms out quickly. I could certainly draw one, but would it be nice if we have one that's prepared for us, because we're going to probably draw quite a few platforms. So one of the suggestions that we had was take this and make the platform in here. So the way we could do it inside of our tile palette is to select the tile we want to duplicate, click edit, go here and put it in, right? So take it. And once I've done that, you can select which one you want. So click off edit, click the object, click edit, put it back, and draw the platform the way we want it to be drawn. So again, I'm thinking something that's not quite as big as this one. The first one should be probably a little bit better or bigger. And then stop editing, grab the object, edit, and select it. So those are the endpoints. And that's this one. Let's do the other parts. Okay. So again, selecting, editing, painting. deselecting the edit button, selecting, clicking edit, painting, deselecting edit, and going back and forth where I can draw the platform right ahead of time. So that's going to be my platform. I'm going to regenerate this over and over again. And what I can do then is kind of select the entire platform and then just stamp it in, right? Which is very useful since we're going to make platforms all the time. Oh, that's funny. I could also make rule tiles. Okay, cool. Let's put this inside of here, and let's see if the distance, let's say 3 and 3 up is good enough, right? And let's see how that works for the player. So player, we're building up the level a little bit, and let's see how that works. So we can see that we can, whoa, get way up there now. And the reason for this is because of our air control, right? So I can do this, right? But I've got quite a bit of air control. And the problem with this is it also adds in some weird effects. And that's why I said when we added air control, right, we should also think about tweaking some of the movement mechanics, right? Okay. So a little bit different than we saw before. Cool. So this is okay, though. The distance is fine. Let's make another one that's upper, kind of a little higher up. So again, selecting that other platform. And we're going to put it so that it is going to be, we're going to climb. Instead of it being at the same level, let's make it so that it's 3 over and 1 up. Can we get to that level? Like we really want to detect what our ability is. I think that's probably too far. And let's see if I'm right. And again, so whoop, we fell off, right? And we're on top of there, we can make it, right? We can even make it to this one. So 3 up or 4 up and 3 across, right? So that's not bad. It's a bit of a challenge, but we can do it. One thing we can do to stop the player from sliding the way we did is inside of materials, we created a platform material where we had a friction of 0.2. Let's make that go back to 0.4, right? So that'll add to the friction. So it'll stop us from sliding as much, right? I think we didn't do that in the first one, but it's going to make it so it's a little snappier when it comes to this, and especially when it comes to falling off the platform, right? It won't slide as much, which is not what we want to do, right? Pretty good. All right, so that is the platforms. Let's make one more, and the other platform will be way down here, but it'll be way too far to get up there. So let's add that in. So again, clicking on the platform layer, let's add a problem, and the problem will be a platform that we fall onto, something that's like kind of down here. There's no way, and the position is way off. We're not going to be able to get up here anymore, right? So again, to test that, we can take the player spawn point and we can move it across, right? We can say, what if we started down here, as an example, can we jump up to this level again? And the answer is, of course, we cannot. There's no way we can get up to that. Even if we were to jump, and even if we tried to jump and jump again, right? We can't make it, right? No way. So that is too far. But what if we had a moving platform that took us up and down or right and left? And that would be the first platform that we talk about from a one of your assignment platforms you have to make. Remember, you have to make 3 of your own platforms. Let's give you 1 of yours, the moving platform. One thing to also note is, what if this is at the wrong level, right? This is a problem. How do I move that? Again, I can select the platform layer, click the platform, and then these other controls, I can select the leftmost object, right here, the leftmost selection. And then I can actually select an object that I want to move anywhere I want. So I can do that in real time instead of redrawing it, which is really helpful. So if I put it too low, or if I put it too high, I can move it down to where I think it should be. And that's what these controls allow us to do. All right, so that's cool. So how do I add a moving platform? That's a challenge, right? I can't add it in another layer. That's not how it would work, because in another layer, the whole layer would move up and down if I made a platform that moved. So the other way to do it is to add it in as a sprite, right? So that's cool. Well, we have our external assets. If I go external assets, Sunnyland, and if I go to artwork, environment, tile set sliced, and if I click sprite editor, you can see that this one is tile 0, this one is tile 1, this one is tile 2. Let's not make it all of these, just the first layer and the second layer. So the moving platform will actually look thinner than the other ones, just for demonstration purposes. So we can say that we want 0, 1, and 2, and we also want 34, 35, and 36. So where are these numbers and why am I saying them? Well, because you can open up a tile set sliced inside the inspector. You can see 0, 1, and 2, and 34, 35, and 36 are further down. And you can select each of these unique sprites and pull them into the scene, like so. So here's the first one. That's the top part. I'm just going to move closer here, right? And I can move the second one in there. And let's suppose we're just going to use these as, I'm just going to use these ones just for sizing. I'm going to use this platform here for sizing. So I'm just going to pull these down here, right? So I'm going to say that whenever I want to move one tile next to the other one, I can use V snapping. So I can use the V key, right, with the platform that's selected and select any vertex, including the middle, and then pull it to the left. It'll snap right to the other one, okay? So I want to duplicate this one and pull it aside, and then use V snapping to snap it back in. Duplicate, pull it aside, use V snapping, and pull it back in. Oops. And pull it back in. There we go. Duplicate this one, right? And then use V snapping and pull it back in. We don't have to make it the same size of this. We can make it maybe up to here. So a couple more. And then the edge, which will be number 2. So now that we have the platform on the top, we need the platform on the bottom. So that's 34, 35, and 36. So 34. Okay, so V snapping. 35, which is the one that repeats. I'm just duplicating with Control D for everyone to see these. And finally, the edge one, which is 36. There we go. All right, so that is your platforms. All right, so that is going to be my moving platform, but I want to create another object. I want to make our first prefab for this thing, which is all of this. So I want to select from the bottom to the top, right? And then I want to right-click and select Create Empty Parent. And then we'll name this parent platform. Okay, so that's our platform. We can move this thing around now, the whole thing. And it's not limited to the tile set in any way, okay? What we want to do is we want to make this a prefab, but first let's add a couple of additional things. Let's add a component, which is the Box Collider 2D. We also want to expand the size of this. So if I go to hit the Box Collider and start expanding, you can see that approximately it goes to about here, which is about our size would be 8. And our offset is 3.5. Okay, approximately. And if I expand it this way, it goes to here, which is about 2, with our offset being about negative 0.5. Okay, so that is the numbers, 3.5, negative 0.5, 8, and 2. And that gives us a pretty good collider for the platform. We want to do a couple of additional things, right? We know that the player is going to land on the platform, and so it should have a layer of platform for everything. And we also know that we want to tag this thing as a platform later on. So let's create a another tag instead of the player or the other stuff. Let's add another tag that we're going to call platform. Okay. And we're going to assign this platform both as the tag platform, so we can identify it, as well as the layer platform. Why? Because instead, the name of the platform may change because we're going to make prefabs, but the tag will never change. It'll be the same name. So we can identify it by tag if we want to. Cool. So we've got our platform and it's working pretty good. Let us kind of drag and drop it into a prefabs folder, which we'll create. So we'll call this prefabs, and we'll drag and drop the platform into there. There we go. And now we can add as many of these platforms as we want. But we want a special version of the platform that we want it to use. And by the way, let's try this out for the player, right? So if the player starts there, we should be able to jump on the platform, move around it, and all that stuff. Let's try that out. So, right? No problem. No problem. Right? We can jump, we can move off it, we can die off of it too. So that's the platform. So we want to make a special version of the platform called a moving platform. So let's rename this. We're going to use the platform prefab as a template for other platforms in the future, right? And we're going to drag and drop this moving platform and make an original prefab of it, right? So moving platform is not just a platform, but it has other qualities. We're going to add a script to it. So we're going to add a brand new C# script called moving platform controller. And the moving platform controller is going to be attached to the moving platform. And we're going to save this as an override, apply all, so that all moving platforms have this moving platform controller attached to it. Awesome. I want the platform to have the ability for me to move horizontally, vertically, and diagonally. Those are the three states, if you will, of my movement. So before we do anything with the moving platform controller, let's add those states. So add a new C# script. We'll call this moving platform direction, right? And the moving platform direction, give it a sec. There it is. Will be another enum. So again, we don't need any of this. We don't need this. We'll make this a enum, right? And maybe add in a curly brace that I took away by accident and make the system serializable. And we'll say that the direction is going to be horizontal, vertical, diagonal, up, and diagonal down for now. And we'll also have a number of directions. Okay. Again, like Kira said, you can probably figure out how many of these are without using this, but it's a quick lookup. All right, so horizontal, vertical, diagonal up, diagonal down, number of directions. This is what I want for my moving platform direction, right, where I'm going. And of course, I'm going to include this inside of my moving platform controller. So going back to the moving platform controller, let's decide all of the things that the moving platform is going to have, right? And we'll get into that right now. So the first thing is, when we think about it, here's my moving platform controller. I want to go and put a section up here. So we'll say that the header is going to be movement. And we're going to have a couple of things I want. Move public, a moving platform controller, platform direction, which we'll call this direction. So we'll track or set the direction of the moving platform. At the beginning, we'll test it with horizontal only. We also want to have a public float speed and a public float distance. Okay, we also want to know that if we want to turn on looping or not. And we can say that is looping. is a looping platform. So it kind of loops back and forth in the direction that we tell it to go to. For the speed, we definitely want a range, right? And we want to set the range to 0.1f to something like, and again, I'm going to start off with 10, but you can make it something more than this. And the same thing goes with distance. Maybe we only want it to go up 10 units, whatever that is. Maybe that's not enough. We can test for this. Maybe 20 is, after doing it earlier today, I think maybe 20 might be more of an appropriate distance, okay? And maybe a minimum distance of 1, right? So 1 to 20. In fact, if you really want to, you can make this an integer value. So it's always a distance that is an integer. Okay, so that's kind of movement. We also want to know when we do our movement, what's the starting position of the platform. So we'll put that in as a private variable. So what's my starting position? And we're going to say that at the beginning, the starting position is equal to the transform dot position of the object, all right? Because that's going to be our offset. We're going to start from there, and then we're going to move right, left, whatever. We want a move platform method. So private void move platform method. There we go. And here's the move platform method that we're going to call. And at the beginning, we're going to ignore looping and all that kind of stuff. What we're going to say instead is we want our transform dot position, right, to equal a new vector2 object. And we're going to say that we're going to start with our starting position dot x. That's what we're going to start with. Plus, we want to add, we're going to use a math ping pong, just like we did in the first section of the, or first half of the class. Mathf dot ping pong, and we're going to pass in time dot time, and we're going to multiply that by speed, right? And we're going to go for a particular distance, and that is the x-axis. And then we're going to add in our transform dot position dot y. So that we're saying here is we're saying, hey, just uncheck this for a second and pull this back so you can see it all one line. We're saying this, we're saying every frame, our position is going to change. We're going to make it a new vector2, starting off where our original position was, wherever we placed it in the map world space, and we're going to add to the x-axis a ping pong value that goes from 0 to something like the distance, which is, let's say our distance is 10, to something like 0.99 of the distance, 99% of the distance. So in other words, like 9.9 plus the original x position, all right? And then when we hit 9.9, we're going to start counting backwards, 9.8, 9.7, 9.6, 9.5, 9.4, all the way till we get to 0 or close to 0. So it's going to go from a 0 to the distance. And we're going to keep on ping-ponging between these two things. What we're really doing is with ping pong is we're interpolating, we're using linear interpolation, and we're thinking about a line segment that we're traveling across from point A to point B. And we can look at it kind of like this. We say for a point A, as an example, and we're traveling across to point B, 0% as we approach B, 1, kind of a normalized value, would be 100% of the distance, right? And then 0.5, if we were going to draw kind of the middle somewhere, let's just draw the middle. So somewhere in the middle, let's say around here, and maybe we can draw a better line than that. There we go. Let's say this is approximately the middle. It's not, but let's just say it is. This would be 0.5 for both going towards A from B and from going from A, so from A to B or from B to A, this is about halfway, not really, it looks like a little bit closer to this side, but let's suppose it's a little bit halfway between the 2 points, right? So as we're approaching B from A, the T value, which is the interpolation value, is what it would increase. It would go from 0.0 to 1 to 0.1, 0.2, 0.3, 0.4, 0.5, keep going until 0.99. And then we're going to, once we get to B, it's going to flip around and it's going, okay, now we want to go from B to A. The interpolating value is 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, 9, 9.9, and then turn around and go the other way. Kira says a different way to do this would be to give it an array of pathing points and use vector to move towards. Yes, we could do that. Right, we could definitely do that as well. But and it's totally up to you how you want to do it. But if you try it this way, what it does is a kind of a very simple solution to move it across. Let's try it and see how it works in the game. But it's going to, simple solutions also present some issues, right? So we'll talk about what the issues are. So if I run this thing now, you'll see that we cannot put any zeros here. We have to put at least some value. Let's use the speed of 2 and a distance of like 8. I want to use a value of 8. You can actually type it in. All right, so 2 and 8. And we don't care about looping right now. We're not dealing with that. But if I press play, then it's going to move. And if you look at it from a scene perspective, right, then you can see that it moves this distance until it gets to a distance of 8 and then moves back. So that's the ping pong effect. Make sense? And that's horizontal. So let's fix up what vertical would look like and everything else. Well, we haven't used the direction yet. So let's do that. We can use a switch case, right? So we can say, hey, let's switch on direction. And what we want to do is we want to say that moving platform case, moving platform horizontal, then do something, case moving platform vertical, then do something different, and moving platform diagonal up, something even more different, and diagonal down, do something else. Okay, so that's the cases. We can take this line here and we can cut it and put it onto the horizontal piece. And then we can take the same thing and put it on the vertical piece. But now what we want to do is we want to move this part out. So cut it, move it here, and then go make this the X value. And then make this the starting Y, whatever that is, plus this. And that's really vertical. So again, we start off, the transform position at X never changes, but the starting position dot Y is where we start. And then we're going to ping pong on the Y side only. Okay, so if I was to show you that, and if we select vertical instead of horizontal, press play, then it should work the exact same way, but just up and down. And now this might give us a chance to have some other platforms that will get us to back to the other way, or some to help us get, kind of back to where we're supposed to go. Okay, so up and down, left and right. Okay, cool. What about diagonal? Well, diagonal up is like both, right? So we can take this one and paste it. And let's paste this one. We'll paste the other one second. And then we take the first part of the first one, which is this part, and add it to this part. So now we have both the ping pongs on both the vertical and the horizontal. And we did it in the wrong one. Undo. We want to do this one over here. There we go. And that would be for diagonal up. And to test that, we can go here and set the diagonal up where we want to go and press play. And that would allow us to move up at the diagonal, at the low. Whoa. Something went wrong. Let's take a look at what I did. Transform X and Y. What the heck happened here? That was weird. Oh, ha, ha, ha. Totally wrong. This should be starting position plus. So this part. Otherwise, it would be bad, right? So we don't want to add to transform position, or else it would be like crazy. Starting position is what we want. So let's try that again, and let's try it. Make sure it works. And we should have a diagonal moving up. Let's see. Yep, there we go. And it's going to move back down. And same thing goes if I wanted to take this one and I want to move the other way around, then we're just going to do one change, which is going to be, instead of adding, we're going to subtract on the y-axis only. Everything else is the same. So again, some minor changes, but you can see that this is not terrible in terms of coding. Easy to do, right? The looping part is the part we worked on at the end. It took up a lot of our time, but you can see that we've only spent an hour of our time together, and compared to the hours we spent together with the other group. There we go. So there's how this goes. This is kind of diagonal down, where it kind of goes down, almost like a little elevator that goes down. All right. So what about if I don't want it to loop? And by the way, starting position is a huge thing. Right now, the starting position is something that I've preset, right? So I said the starting position is always the original position, but I can always make the starting position of the platform separate, right? So it's actually like a child of the moving platform object, right? So whatever that starting position is, because then I could kind of go from start point, like you said, Kira, to an end point, start and end points. And then the platform itself could be actually the tiles that make up the platform could be another sub-object that holds all the tiles in place. So my start point, and I have an end point of each platform, right? And then I can do is I can say move towards, right? And when I get there, I'm done. And then when I'm going to move back, I can get there and I'm done. That's another way to do it. But how can I do it using my existing code? Is there something that I could do instead of doing it that way, right? So what would you do if I want to say this only happens, this direction switch stuff only happens when I'm looping? So if I'm looping, then do this. But if I'm not, then do something else. So one way of doing this is if I'm looping, then when my time goes to max, so when my math f ping pong is close to the distance, right, is what we said, right? Something like up here, instead of my math ping pong, right, being included in all of these places, here and here and here and whatever, this math f dot ping pong I can make into a variable that's once, and then I'm just adding that same thing over and over again or subtracting it. So this would be like the ping pong value, if you will, right? So, or the call it the the move offset, or the the platform offset every frame. Every frame we're moving it further along or less from the original starting position. So this kind of the offset, right? The ping pong offset. We'll call it the ping pong value for now, right? So again, we're going to say float. We'll call this the ping pong value, right? And that's going to be equal to this math f dot ping pong. And once we pull this over here, we can actually replace this part by all this. So that's not going to change. So this is ping pong value. It makes these things a little bit more readable too. And we can always rearrange the ping pong value to something else. We don't like that name. But like I said, what it does is it makes this whole line a little more readable and understandable of what's happening. And it's less calculating or calling that function over and over again, which is probably more efficient to do it this way. So one of the cool reasons to do the way I said earlier with pathing points is that you could use onValidate to move the platform's position to the destination. That way the designer can see where it'll end up. Yeah, I like it. Yeah. So again, using like a start point and an end point as opposed to a and actually with pathing points, what you can do is you can make it do all kinds of really cool things, like some kind of roller coaster or whatever path you want to take. You can keep moving through an array of points, so it's awesome, and keep moving towards those array of points. But this is just another way of doing the same thing for a moving platform that goes back and forth, right? So again, so let's think about this. So the ping pong value, we can kind of debug log that. Let's look at that. Debug.log, right? Ping pong value. And what is that value, right? And let's take a look. Let's move this from the diagonal up to just to vertical. And so we can see what this does, right? So let's take a look at this thing here and see what the values are that we're going to get. And the value that we're going to look for is the one pretty much at the bottom. You see how it moves from 0 to 0 0.03, 0 0.7, 0 0.8, 0 0.84, and it moves moving, kind of more and more towards, all the way to the distance, which is 8. And then as it approaches 8, it gets almost to 8. Take a look at that. So you can count the values, right? And they're never exact. That's the other thing. To Kiera's point, you can see that each value, as we approach 8, let me just move that closer to 8. So 2.5, 5, 6, 7. And then as you get closer to 8, look how close you get. 7.93, 7.94. And we get to 7.99517, really close to that value. And then we move back the other way. All right, so not quite 8. We don't quite hit 8 before we go back. So that's the thing to do. So that value, right, whatever that value is, if that value, the ping pong value, and it's always going to be a positive value, whatever that is, if it is, greater than or equal to whatever the value is that we're looking for, minus something like small offset, you can actually look at something called, if I'm not wrong, there is actually an approximately. So if, if I wanted to look at mathf dot, and if I look at approximately, where I want to say it's approximately equal to, they're very close values, close to if they're very similar, right? Because floating point values are hard to compare. So I can say the ping pong value and then the value of the distance. If they're very close, if that's true, right, then we can say that we'll do a debug log and we'll say that that's true, okay? And we'll not do this anymore. So let's see if that ever happens. Let's see if we ever get that true result, right? So we're using mathf.approximately, which is actually close to what you asked earlier, Kiera, which you said something like, hey, what about that epsilon value, right? So let's see if this works. So we're working, and as it gets to the top, do we ever get approximately to the distance? And the answer is not quite. Not quite close enough, right? Approximately is a great little thing if we're really, really close, like 0.00000, but not quite exact, right? That's what approximately does, right? So if they're similar. And we could do an offset. So minus some kind of offset, right? And we can call this the platform offset. We can look at the distance offset. So public float. We can say the distance offset. And that distance offset is going to be something like, we'll make it a range. of something like 0.1, well, let's say 0.05 F to 0.1 F, something very, very small. All right. That's what the offset should be. If I go back to what did I leave out? Oh yeah, here. Distance offset. And if we go back to the distance offset, then we can assign a value, something very, very small, like 0.05, right? Something like that. And that distance offset will be very close to it, but not quite there, right? So this may be something that you want to do. It's a tweakable value. And then let's see if that works if I get a true at the top now, if it's close enough. If not, we can adjust this value, right? So even that with approximately isn't the right amount. Let's not use approximately. Let's use it that there. If the ping pong value, right, is, we'll say, greater than or equal to the distance minus the distance offset, which is kind of what we want. And let's put this back to 0.05. Cool, that might be good enough. Something very, very small. There's that true. Came true, right? We can even go with a smaller value, but true. Hopefully we'll get it. So it's both. We got it a bunch of times, right? And every single time the distance, that distance offset is there, we're going to get that value. So why do we want that? Because if it meets that value, something like less than 0.05 or whatever that small distance offset is, then we can say that it's reached its limit, right? It's kind of hit its limit. And if the looping is not true, so if not is looping, right, then we want to deactivate the the motion. We want to turn off the ping pong value. So the ping pong value is only going to be true, right, if looping is on, right? So we're going to say something like this. We're going to say that hey, if is looping, right, then make the ping pong value equal to this. Otherwise, if it's not looping, make it equal to a different value. So instead of the ping pong value incrementing every single time, because we're adding a bunch of things, do we want to use ping pong or do we want to use some kind of our own timer or something like that? So is looping basically says, hey, if I'm looping, keep adding the ping pong value on. Otherwise, make it 0, right? So, but is looping, is that really the proper thing that we want to say? It's really it's almost like is active, right? We don't have an is active. We'll make that a private variable that we deal with. So here's a private Boolean, which is called is active, but the motion is active, not the item is active. So we got to be careful about what this says because it might be misinterpreted by the person who's using the platform. So, platform is active is probably what we want to say, right? Moving is active, something like that. So moving is active, right? And moving is active, we can set to true by default. So moving is active is true. Okay, sorry. So, so moving is active is true. Yay, that's great. And what we want to talk about when this is happening is if moving is active is true, then and only then do we keep on ping ponging. Otherwise, it's not, the ping pong value is 0. So then what we're going to say is if the ping pong value is greater than or equal to the distance, the offset, right? And, right, the only time we want to check this is if another condition is true, which is if it's looping. If it's not looping, right? So if it's not looping, and so if looping is set to off, we don't want to loop, then we want to turn off this thing when this reaches this point. So when we say if not is looping and the ping pong values reach this distance, then we want to say that the moving is active is false, which stops the value, stops the item. Okay? So that's a way to kind of make it so that it's not looping. All right, it only does it once. However, if looping is on, it'll skip this altogether, and moving is active is always going to be true. So it's always going to be looping. So that's kind of my simple solution for it, which is similar to what we talked about earlier, but you know, I changed it. I like the ping pong value that you guys, people who watched this earlier, were talking about, which we replaced the ping pong value here. That's kind of a mix between what Maxim was talking about earlier today and Vincent. Okay, I like this idea, and so let's see if it works. So let's go back to this, and if I turn is looping on, then if I press play, it should just loop continuously. Oh, he's moving. I like his moving better, Kiera. I like it way better than my ugly thing that I put in. What if I turn is looping off? Then when I get to the top, oh man, what the heck happened, right? It went to 0. And that's what we said here. It says our ping pong value will become 0. If moving is active is false, then whatever the ping pong value is going to, the ping pong value is always going to remain as 0, which is not what we want. We want it to be as distance, right? So whatever the distance is, we're going to put it to that distance. And let's change this back to, instead of moving as active, let's rename this, refactor, rename to is moving. I'll be okay. Just getting tired. I haven't taken a break. Okay, there we go. Okay. Again, is moving is not something that we're going to see, but it's something that we're going to use. Thank you for that, Kiera. So let's try that one more time. So if it's looping, it's going to keep going. But if it's not, it's going to go to the distance. So let's see how this works. So is looping, goes up and down, right? No problem, because that's turned on. But if I turn it off, then when it gets to the top, it's going to stop. If I turn it on again, right, then how come it's not working? Well, because it won't turn on again, because if we turn this off or on, it won't check. It will never check again to see if it's moving again. So we should check. If you want this to be dynamic, where we can turn it off and on with scripts or whatever, right, or some kind of switch, then we can say that is moving as false is okay, but we want to check to see if our looping is on, right? So we can do that somewhere else, like somewhere in the platform over here. So we can say something like if is looping is on, only then is moving is true, right? So that will turn it off and on. Let's see if that works, or if that's going to create a problem. Okay, so let's try that out. Run. So it runs, and then we'll turn it off. When it gets to the top, it'll stop. And when I turn it back on, it'll jump to the next location. And that's a problem. And the reason why this happens for the moving platform is when I turn it off and on, like it gets to the top, but if I turn it on, it follows delta time or time.time, right? So the thing to do is kind of what Maxim told us earlier today, and for people who weren't here, instead of using something like our time value, which is time.time, right? We can make our own time value, which would start it off again, from, well, it would halt the time value, an incrementer of our own, some kind of our own custom time. Okay. I'm not going to do that here. I'll let you guys do that, but we have a moving platform that goes forward and back and up and down and diagonal right and diagonal down. This is just another way of doing it other than using move towards. One thing we want to do though is the problem with using a moving platform, and let's go back to Unity for a second, is what about when I'm on a horizontal platform and with my character? Let's see what happens. So I jump on the platform. Can I reach it? It's too far. There we go. And take a look. I will fall off. And it's going to happen every time. And the reason for this is because the platform is not linked to the player in any way. So one way to fix this is inside the player behavior. Here's player behavior. And this is the last thing we're going to do before we take a short break, which covers us everything we did in the first half, right? So we're going to say that we're going to make a private void on collision enter 2D with collision 2D other. And we're going to say that we're also going to have an on collision exit on collision exit 2D with other. And we're going to say that if other.gameObject.compare tag is a platform, we kind of fixed this up earlier today, then if that's true, then we want to say that the transform.setParent is equal to the, because this is the player behavior, of the other.transform. So we're going to say that the other being a platform, we're going to make the platform the parent of the transform, the actual object. Otherwise, if we're leaving the platform, then we're going to say that let's set parent to null. To take this a step further, this idea, right, which means I'm going to be parented to the platform when I step onto it compared to when I jump off of it. But we didn't do that for our platform layer, and we probably should to be consistent. So for now, in the platform layer, I'm going to tag that as also a platform. All these platforms here and the grid are also going to be platforms just like this one. So now if I jump onto it, if everything works well, and this is the last thing I want to talk about, so if I jump on there, then I'm moving along with it. Where this is weird, and Chris mentioned this earlier today in what he was saying, right, is if I have the moving platform, and what about if the platform is diagonal down, right? Sure, I'm taking a nice ride, right, with the player, but if I jump, the player's jumping is affected on the way down because of, well, they're going to have less of a jump capability. So it's something that we may want to tweak. But notice how the player works, right? I can move around still. And when I jump, my player becomes unbound from the platform. When I'm on the platform, the player is bound to the platform itself. Okay? And now it's bound to the platform layer, right? But if I jump, you can clearly see that the player becomes unbound from the platform layer every single time. So simple platform is what we got for this one. Any questions when it comes to making a moving platform? And I'm doing it with ping pong. I think the other solution is move towards. I like move towards because you can make the platform behave in any way you like, right? So again, what you could probably do is we have a prefab for the platform, and my moving platform, you can rename this to whatever you want. But for the most part, you can make your own platform do any kind of tricks you want it to do. All right, but you can use the platform that I created for you, or something like it for yourself as a template for the other ones. All right. Let's file, save project, and then exit. And then I'm going to put this up on GitHub. We'll take a short break. We'll come back in 5 minutes. Let's say at 4:58. Let's say 5 to make it even. And then we'll continue for the other hour where we can add some simple enemies. And let's try that now. So I'm going to go to this, and while I'm doing this, I'll answer Kira's question that I saw. So I'll add moving platform. And push. So Kara says, what about giving the platform a rigid body and then setting its velocity? And that would have the same effect as parenting as you just did, right? You're setting its velocity the same, the player's velocity the same as the platform? Is that what you're doing? If you give the platform a rigid body, you're giving it a rigid body so that it gets a velocity as opposed to changing position, is what you're saying. So the velocity would be you would push the platform around as opposed to changing the position of the platform. So that would be a lot different in terms of its motion. But in terms of parenting, I don't know how the parenting would change too much, because still you'd roll off it. If you're on the player and if a platform is moving, it doesn't mean you're moving with it, right? Actually, I'm not really sure. That might work, actually, because now you're using physics to push something. No, it would work. Your way would work as well, right? I'm just doing it because I'm changing position of the platform as opposed to, so really what's happening is I'm teleporting the platform to a new position in micro increments, right? My way, right? Every frame. Your way, you're using physics to push the platform along in a more natural way, right? So you'd add force to the platform. And that might look different too, where you're pushing a platform to the right, it stops when it gets to where it's supposed to go. And then, I mean, you can do it all kinds of ways. You can make it so that it stops with a collider, right? As soon as you're on the platform, you push the platform at a certain speed, and it keeps going, and it just stops. There's no requirement for any kind of code at all, really. I mean, other than the effort to push the platform to give the platform energy. So interesting way of doing things. I mean, I like it. Yeah, you could set the velocity. Yeah, there's a lot of ways of doing this thing. I mean, I would definitely experiment. I mean, I think there's some really great ways of doing it. I'm just doing it the way that I've always done it when I made moving platforms, but it doesn't mean that you couldn't do it your way. And I love the move toward thing because, again, you can, like you said, create a list of path list and then follow the path list. Okay, let me take a short break, guys, and then we'll come back and we'll continue with adding simple enemies and some sensing.